Hi everyone, this is Kari Watkins at Georgia Tech. I'm going to slowly do a little bit of introduction type things so that we can let a few more people join. It's right at noon right now. I've got the group chat open, so if there's anyone having trouble hearing me, let me know, but I know at least the Stride folks can hear okay, so hopefully we're all set. As I said, my name is Kari Watkins. I'm an associate professor at Georgia Tech in the Department of Civil and Environmental Engineering. And Georgia Tech is one of the partner universities with STRIDE, the Southeastern Transportation Research, Innovation Development, and Education Center. Georgia Tech is Georgia Tech is one of many of the partners in this center that's led by the University of Florida, and they periodically do webinars from all of the research that's being undertaken by these partner institutes. In many cases, it's research that's being undertaken by multiple institutes. We have a focus on research that's applicable to the South, to state agencies, transit agencies, any sort of governmental or local institutions in the South, but we try to conduct research that's also universally applicable. So please listen in for other STRIDE webinars that might be of interest to you. So I see that there's a few more who are coming on, but given that it's 12:02, I'm going to go ahead and get started with the presentation that we're doing today. Andine tells me that the entire thing is being recorded, so you should be able to look back for those who've joined us, and you should be able to pass it on to others, and folks who missed the first few minutes should be able to see that. So I'm going to go ahead and close the participants in the group chat so that we can see my full screen. Oops, it's not advancing. There we go. So today what I'm going to talk about is some research that we did here at Georgia Tech. It was actually part of a project that we're doing in partnership with folks at the UNC, at NC State, and at UF. But this is the analysis that the Georgia Tech team did as part of this. And basically what we were looking at is comparing transit agency peer groups using cluster analysis. The motivation for this work is that there's been a change in transit ridership in the United States that is pretty concerning to a lot of people. As you can see from this graphic, especially with the line in red, bus ridership is at its lowest point since 2005. It's actually at its lowest point since 1965. So a pretty long time span, basically as long as we've been keeping current ridership statistics in the way that we do today. And over the last few years, since about 2014, 2015, rail ridership has been declining substantially as well. And so there's a lot of concern about this in the transit industry. And we at Georgia Tech are trying to do some research to understand what's happening with these ridership changes. And so one of the motivations of this was actually to try to understand those ridership changes. Historically, there's quite a few things that have been found to predict transit ridership, mostly service levels, but then also population density, as well as other factors like auto ownership, gas prices, fares. The problem is that much of this research that's been done on all of these types of things, they look at national trends. So they tend to look at the nation as a whole, or they're comparing city against city, sort of looking at the average for all cities versus each of them. But in addition to that, many agencies actually benchmark their performance against their peers. So there's quite a bit of research that has shown that this is a great way for agencies to understand better what's happening in transit ridership, as well as other performance metrics that they might be using. So the Florida DOT created an integrated national transit database analysis system in which they were doing peer grouping with national transit database data selecting some different grouping variables and screening factors. In TCRP 141, this is the Transportation Research Board's research arm, the Transit Cooperative Research Program. They did an integrated national transit database looking at peer groups on a national scale. The National Center for Transit Research has also come up with a method to create peer groups that are geographic region based and then based on demographics and operational characteristics. All of these things have done a lot for helping agencies look at their peer groups, but there's still not a lot of research, and especially not on ridership factors. Yet there are a few things that have indicated that as the metropolitan statistical agency size is different, then as that changes, it can actually change the significance of service frequency and coverage on things like ridership. And so for that reason, we wanted to undertake this research in which we were looking at some of these ridership factors based on clustered agencies rather than looking over the US as a whole. So many of the agencies operate in the same city. So in this case, what we were doing was, instead of comparing one transit agency to others, we're comparing region to region. We found that it was more useful to group regions rather than agencies, especially if we were trying to look at population data and things like that. We use the core-based statistical areas, so based on the metropolitan or micropolitan statistical areas, so those MSAs. We used American Community Survey data as well as National Transit Database data at the time that the work was done. 2016 was the most recent numbers that we could access for the full year. And it's important to note, you won't see New York City in here. So if we have someone on the call who's from New York City, we considered you an outlier. And New York City themselves will tell you that they're more logically benchmarked against other countries. So they're a member of ComMet, and that they benchmark against London and places like that that are more similar in size. So what we did for this, we used Ward's method of clustering. We did scree plots, gap statistics, and made sure that our clusters were easily interpreted. The goal of this was to identify the areas with fixed characteristics that are similar enough in ways that are related to transit ridership. And we picked a bunch of different factors that may come into play in trying to cluster the different agencies. We looked at metropolitan area population, population living in dense areas, % of zero vehicle households, and various measures of transit operations. We also tried to look at many other factors, but it was hard to get data that was consistent on a nationwide basis. So the ones that we ended up going with that we felt sort of grouped the agencies and made a whole picture without having a lot of overlapping data were the population, again, and these are listed on the slide, the % of population living in a dense area. And we used what's known in the transit industry as an kind of age-old measure of 3 or more housing units per acre as a transit supportive density. So we were looking at the % of populations that were living in that kind of transit supported density. We looked at the % of zero vehicle households. This is an indicator that people don't own automobiles and are therefore using transit. So we sometimes call this a transit dependent population. They may be transit dependent by choice in that they're choosing not to own a vehicle because they don't need to. You also sometimes have one vehicle households where there are multiple drivers. That data is harder to come by. So we just use zero vehicle households. And then our measure of transit operating was operating expenses. So we were separating out agencies by the budget that they had to work with, as opposed to any other operating statistics. We used other operating statistics in order to see differences to see if that compared to transit ridership. So I'll get back to that later. Then when we did the cluster analysis, we did it for 2 different categories. We separated out transit services that operated in mixed traffic. So intercity bus, commuter bus, bus rapid transit, streetcar were all put into this category. Sometimes bus rapid transit runs in its own dedicated right-of-way. Unfortunately, the NTD, National Transit Database, statistics aren't good enough to truly separate out how much of the BRT is in its own dedicated right-of-way. So we simply put all of that in with the other bus traffic. The other cluster analysis we did was services that are running in dedicated right-of-way. So these were heavy rail, light rail, which again could be in mixed traffic, but is predominantly dedicated right-of-way, monorail, hybrid rail, and we only looked at systems with 1 million or more unlinked passenger trips per year. So these were the 2 different cluster analyses that we performed. The result was that for our mixed traffic, we came up with 5 clusters. It was mid-sized transit oriented. So this was predominantly older industrial cities in the Northeast and the Midwest. They had declining population and much higher zero vehicle households. Examples of this, Albany, Baltimore, Pittsburgh, and Cleveland. I'm actually gonna click back and forth between 2 different slides so that you can see a map that we produced of these. So this shows all of the 5 mixed traffic clusters that we came up with. So again, that cluster 1 was predominantly in the Northeast, although there's a few cities and other places that had similar declining population with higher zero vehicle households, so that it was grouped in with those Northeast and Midwestern cities. Our second grouping was mid-sized, more auto-oriented cities. These were primarily a little bit smaller and more recently developed cities in the Midwest and the South. So again, you can see with 2 that we're talking straight across the middle of the country, across the South, a little bit smaller cities in some cases, but all quite a bit more auto-oriented than some of those in cluster 1. Cluster 3 we called sprawling small towns. These were some of the smallest cities and college towns. They tended to be the least dense, the least populated, and spent the least on transit. So some examples are Lansing, Burlington, Blacksburg, Knoxville. These are the ones in the green, the 3rd cluster here. So you can see they're sort of peppered throughout the US, but it's those smaller cities. Number 4, our 4th cluster was sprawling metropolis, as we called it. This was larger cities with lower zero vehicle households and higher operating expenditures. So higher operating expenditures than the other clusters, 1 through 3, but lower zero vehicle households. These tended to be sort of the more sprawled, less dense cities like Atlanta, Houston, Denver, and Phoenix. You can see them here in the yellow or the light yellow. And then our 5th category was dense metropolis. These were the largest metro areas that were very dense and also had high operating expenditures. So cities like Boston, Philly, Chicago, Seattle, Miami, they tended to be a little bit older cities predominantly, rather than ones that have developed more recently in the West. Although, you know, a few West Coast cities, as you can see, grouped into that category as well. So remember, these are just mixed traffic clusters. So these were just looking at the bus ridership in each of these cities. Then for our dedicated right-of-way clusters, these were the clusters that had rail or light rail systems, and so there were less of them that were active in the cluster analysis. We again came up with 5 categories, and I'll go over them on this slide, and then I'll flip to the next slide so you can see a dendrogram showing how they actually grouped. The first was Los Angeles. It was an outlier. We expected New York to be an outlier, but Los Angeles was actually one that didn't easily group with the others as well. The second was dense metropolis. So these are large metro areas with extensive transit systems and commuter rail networks. They tended to be denser than the LA area and a lot of the older cities like Chicago, Boston, Philly, but also San Francisco, DC. Then we had a category for mid-sized dense. They were relatively small, compact, but had high zero vehicle households. So these were a little bit smaller cities, but still pretty high, transit dependent populations in Baltimore, Buffalo, Cleveland, and Pittsburgh. Then we had mid-sized, dense, but more auto-oriented cities. So these were mainly in the western states, again, low zero vehicle households, but still pretty high density. So San Jose, Miami, Portland, Seattle, Phoenix, etc. And then finally, sprawling metropolis. These were pretty similar to the bus sprawling metropolis in the other cluster analysis. They had these are the large metro areas with relatively few dense census tracts, so Atlanta, Dallas, Houston, etc. So here you can see a dendrogram that was produced in the cluster analysis that we were doing, and you can see, I think I have a pointer. Forgive me because I don't do this pretty often. Actually, I think you can see my screen, so hopefully you can see my mouse. So you can see that there was a first break between A and B, so the Los Angeles cluster and the one that included San Francisco, DC, Chicago, and Boston. They were seen as more similar to each other than C, D, and E. And then C broke off from D and E, and then finally D and E were separated from each other. So then the point of doing this cluster analysis was for us to actually try to look at how transit ridership was changing for each of these different clusters. So we started with a trend analysis of the dedicated right-of-way. And what we did was looked at the percent change in unlinked passenger trips. That's what UPT is in all of these graphics. And we graphed that versus the percent change in population. And so on here you can see that the overall trend line, the R-squared, was 0.46. But you can see that the clusters kind of form in different places on here. But there's definitely a strong relationship between the changes that are being seen in population and the changes that are being seen in ridership across the US for dedicated right-of-way. When we also looked at vehicle revenue miles as a measurement of how much service is being provided. So again, for the dedicated right-of-way, so the rail-based cities, we looked at the percent change in unlinked passenger trips versus the percent change in vehicle revenue miles. And this had an R-squared of 0.27, so a moderate relationship, not quite as strong, but still a moderate relationship between the changes we're seeing in ridership and the changes in the amount of service being provided. Although you can see that there are definitely some outliers. I'll tell you that one of them was Houston and Seattle. So Houston has added a lot of service recently on their rail network. Seattle has added some, but the increases in ridership that they've seen in response to that are outstanding compared to a lot of the other agencies. So a few of these outliers are kind of driving the relationship that we're seeing. Then we also did these same analyses using our mixed traffic clusters though, and we saw some different results. In looking at changes in population versus changes in ridership, this first slide, I'm showing you cluster 2, 3, and 4. So 2 and 3 were the smaller cities. 4 was a little bit bigger, those metropolises. But all of these were the ones that were a little more auto-oriented. So in these more auto-oriented cities, even if they were seeing an increase in population, as you're seeing with all of these graphics, the zero axis, most of them are seeing, most of the regions are seeing some sort of increase in population, except for just a few in cluster 3. But despite those increases in population, they're really not seeing increases in passenger trips, in unlinked passenger trips. There are a few cities that certainly are, and they're seeing some pretty large increases in passenger trips, but there's really no relationship between that and the change in population that they're seeing. So ridership for the mixed traffic, at least, so the more bus-based services, seems to be unaffected by changes in population. In looking at cluster 1 and cluster 5, though, these were the clusters that were a little bit denser. Cluster 5 is the large metro areas. Cluster 1 is more mid-sized. There was a little bit more of a relationship there. It was still not a substantial relationship. Cluster 1 had an R-squared of 0.15. Cluster 5 had an R-squared of 0.14. So there's a slight trend, but it's not necessarily really strongly explaining this variation in ridership that we're seeing. Then we looked at vehicle revenue miles. So this is the relationship between the amount of service that's being provided and ridership. So you would hope that agencies that are putting a lot more service out there are able to have ridership gains in proportion to that. So as they're increasing their vehicle revenue miles, we hope to see an increase in unlinked passenger trips. You can see that for the mid-sized cities and even the smaller, more like college town sized cities, there was a relationship. So you can see the R-squareds on there, 0.22 in cluster 1, 0.38 in cluster 2, and 0.18 in cluster 3. So they demonstrated a similar relationship that was substantial enough to show that this is occurring. But one of the most interesting things from this was actually that the intercept for all of these is negative. So you can see here that as it's crossing the zero axis, so with no added service, there's a negative ridership. With no added service in cluster 1, there's also a negative ridership. And with no added service in cluster 3, there's actually a negative change in ridership. So without adding service, with no change in service, on average, these cities would be expected to be dropping 8 to 12% in their bus ridership, which is not a good sign. Then we also looked at cluster 4 and 5, and here there was definitely not a relationship between ridership and service. So there were cities or regions that were adding ridership and were adding vehicle revenue miles, and in some cases they were seeing no change in ridership as a result of that. In some cases they were adding vehicle revenue miles and seeing a change in ridership. It was kind of across the map, so not the same sort of relationship. So the recent decline in ridership in larger metro areas did not seem to be correlated with the decline in service levels, which is one of the historically best predictors of ridership. Most metro areas in both clusters both increased service and lost ridership. So that doesn't bode very well for the industry. So I have quite a few more slides after this talking about where we're going with the rest of this research, but just to conclude a little bit on some of the, just to summarize things that I've said so far, as well as to point out some takeaways from the research. Changes in ridership are not uniform across modes and clusters, so it's important to do these kinds of analyses. We think that we did a pretty good job in clustering these agencies together, but there, could be more work in trying to come up with, quote, the perfect clusters to do this. But one of the important things we want to say is that doing this kind of analysis where you're looking at similar agencies and the trouble that they're having with ridership is really important, because there's different phenomena across different types of cities. The change in both population and service levels were closely associated with the change in ridership for dedicated right-of-way. So these are the more traditionally rail-based modes, places where transit is running in its own space largely. But that wasn't true for the mixed traffic modes. The changes that were occurring in population had little correlation with changes in ridership on the mixed traffic, more bus-based modes. The change in service levels was correlated with ridership for the mid-size and small metro areas. Well, I'll come back to the rest of that bullet point. The change in service levels was not correlated for the larger metro areas, though. So having increased service was not necessarily producing increased ridership, and in some places, they increased ridership without substantial service and vice versa. One of the really important things we took away from this was that across small and mid-sized regions, if they didn't change their vehicle revenue miles, so if they weren't adding service between 2012 and 2016, they would expect an 8 to 10% loss in ridership. Some of our estimates were even higher than this. So there are some other factors that are causing the decline in ridership. And it's really important for more research to be done to investigate some of these causes on a more disaggregated level in particular, because there's been some analysis done across the US just comparing transit agency to transit agency, city to city. But I think looking at the dynamics at play within each of these cities is really important. So because of that, we have a few more sort of takeaways. Rather than comparing single transit agencies against average performance metrics, we think it's more informative to be grouping agencies to compare these kinds of trends. To date, there hasn't been a lot of research looking at agencies grouped based on their demographic and land use characteristics. And we would actually like to follow on to this research to add more demographic and land use characteristics in the grouping. Some of the data that we were hoping to use related to sprawl and these types of variables, it was very hard to come up with things that were consistent across the entire US that we could look at all of these different, especially some of the smaller cities. We applied this at the metropolitan rather than the agency level, and we think this is important. It enables us to be looking at population type, like census statistics that we could be using. And we think that a lot of these agencies should be working together to meet the needs of their regional population. And so comparing, one small agency that is only part of a larger region is not as useful as comparing them all together and their ability to serve that region. So an important takeaway is that clusters can be used as peer groups. These clusters that we have come up with, we think would make very good peer groups for transit agencies to use to benchmark. And we're actually working with our own local transit agency, MARTA, in their use of this in order to benchmark against the agencies that clustered with them through our analysis. So then the other part of this is that we have some ongoing research. This was a year one project from the STRIDE University Transportation Center. We have a year two project called Changing Access to Public Transportation and the Potential for Increased Travel. That project is again a partnership between Georgia Tech, UNC, NC State, and UF. And there are several excellent research studies that are going to be coming out of that you can look forward to, more webinars and reports coming out on the work that we're continuing. And I'm going to talk about some of that on the next couple of slides as well. Our match money for that here at Georgia Tech is coming from our local transit agency, MARTA. And so we have some work that we're finishing up for them that we should be able to publish some of the results of so it can be used more widely as well. And then in addition to that, my team at Georgia Tech has two transit cooperative research studies. One that's one of the J11 projects that we've just finished, and the report should be out this summer, called Analysis of Recent Public Transit Ridership Trends. And then a second one, A43, that we're just beginning, Recent Decline in Public Transportation Ridership Analysis, Causes and Responses. So you can look forward to the results and look for the results for both of those as well. To talk a little bit more about the ongoing STRIDE research before I go to questions, what we're trying to do, the Georgia Tech team, through this, through the first year as well as some second year funds, is looking at service allocation, so the relationship between ridership and frequency. One of the things that many agencies have been doing is network redesigns, in which they're trying to do more of a frequency-based service instead of a coverage-based service. And so we were hoping to analyze how well that relationship works out in some different cities. The second question that we're looking at is in gentrification. So looking at the economic displacement that's happening in some of these cities, especially the larger metro areas, and how much that may explain the ridership decline. And then finally, we have a unique partnership with a major TNC. And so we're hoping to look at the transportation network companies and what sort of impacts they may be having on ridership decline. And we're trying to do that on more of a disaggregate level. So just to give a little bit more background, we're doing this in Portland, Oregon, in Miami, in Minneapolis, St. Paul, and in Atlanta. So here's some graphics showing transit ridership change that they've had in each of these cities throughout the city. So this is using a lot of different data, not just looking at one statistic for the city as a whole, like the research I talked about today, but we're actually using automatic passenger counter data from these cities. These are the systems that typically have laser on vehicle doors, where they're actually getting counts of the vehicle, sometimes on a real-time basis. And it's connected to GPS, so you can get stop level data instead of just route level data, as you often can with agencies. You can only get route level data from some other like fare media and systems like that. It is definitely big data. It's often used for planning and scheduling and not system-wide ridership counts. But in this case, we're working with agencies where their APC data is good enough that they're able to do that kind of work. We're comparing this to the general transit feed spec for each of these agencies to clean the APC data a little bit. And then we're looking at LEHD, the longitudinal employer household dynamics, and the ACS, the American Community Survey data to get population type data. We also have, like I said, some unique data sets that I can't talk about too much, working with with a major TNC. And then we've been able to partner to get Zillow data looking at housing selling prices and such. So we're wrapping all of this data together and looking again at those 4 cities and what's happening within the city at their transit ridership. Where is ridership up? Where is ridership down? And how can we best explain the phenomena behind that? That research is therefore forthcoming, so you can look forward, like I said again, to some future webinars related to that, as well as the work that's being done by our partners at UF, at UNC, and at NC State on this project. My contact information is here, and we actually have a survey that we eventually want to have people take, but I see that a question came up, and so I'm gonna open the group chat, and hopefully everyone can still hear me and can see the group chat. I think, Andine can correct me if I'm wrong, I think the easiest way to do this is to have you put questions in the group chat if you have a question, although we may be able to open it up so that people can verbally ask their question as well. I'll let Andine handle that. But let me take the first one. Andine says group chat is great. So the first question, Gainesville realized ridership increases when we changed the type of service. Use cutaways with greater service frequency. That mimics Uber type service. Would you evaluate the impact of that type of service in your next phase of study? So what I will say is that through the TCRP work, we haven't yet picked the cities that we're doing. And so if Gainesville has very good ridership data, we'd love to talk to you more. I don't know if Chris is from Gainesville or just works with them, but we would love to work with some other agencies if you have really good stop level data or even route level. There's a lot of analysis that is going to be ongoing through those TCRP studies. And so circle back to us. I will say that for the 4 that we're doing through the STRIDE research, they're a little bit more mid-size. And none of them are actually doing major services like that, but we are using the data that's coming from the TNC. So Uber, Lyft, for folks who don't know the term TNC, we're talking about Uber and Lyft. So not mimicking those types of services, but literally those types of services and the effect that they're having is what we're trying to look at through that. So let me know, Chris, if that doesn't answer your full question. And if there's any other questions, please add them to the group chat. I'm going to give it just a couple of minutes in case we have anybody who's typing. Please don't leave us yet because I think Undine really wants the participants to do the survey that we have. It's really informative for STRIDE. Okay. I'm going to put this up here. I guess it would be hard. So Undine, they're going to have to actually type this in order to be able to do the survey, correct? There's no way that they'd be able to click on the screen. So apologize for that. But please, if you don't mind, see if you can type this survey address in on your computer. Oh, she says she'll send the link out to everyone afterwards as well. So if you're unable to do that, but we would really love your feedback on this webinar specifically. And then I believe she has a couple of questions in there about other things you'd like to see through the STRIDE webinars. Are there any other questions that I can take about the presentation? Okay, I'm not seeing any. If somebody is typing a question, maybe quickly. Oh, okay, Undine actually put the survey into the chat, which is a great idea. So you should be able to click on it through the chat if you're able to take our survey. Anyone else? Please just flag if you have a question, even if it's going to take a minute to type it in. Just let us know so that we don't cut things off. Undine saying in the group chat, it's a very short survey and helps us plan future webinars so that you'll be interested in the content of those webinars. So we appreciate your time in taking the survey. So I just wanted to thank everyone again for your participation. If you have any follow-up questions, I'll actually go back in the presentation. This is my email address here, and I'm happy to take any follow-up questions. If there are transit agencies that are on the line and think you may have interesting data sources that we can work with, and in the follow-on work to this, again, it's part of a larger effort to really understand what's happening with some of these more major transit ridership changes that we're seeing across the US. Well, we have another question. Can this be applied to rural demand response transportation, or have you considered creating these kinds of peer clusters? Yeah, so when we were doing this work, that's a great question. When we were doing this work, we limited it and we didn't do demand responsive transportation. We only used agencies that had some sort of fixed route service and were large enough to be reporting to the National Transit Database. You could certainly be doing this same cluster analysis with more demand responsive services. You'd have to have a data source that's looking at all of those. So if not National Transit Database, there'd have to be someplace else that you're pulling data about these smaller locations. And you may not cluster them in the same ways. We definitely had more of a city outlook to this, even if many of our cities were more mid-sized or smaller cities. We were looking at things like population density. I think if you were doing this for rural or demand response and you were trying to cluster agencies together so that they could be compared, you might look at some different factors. But I think that would be a fascinating analysis. And if Jeremy happens to work for a transit agency that is really trying to do a better job with the demand responsive services, I highly recommend that what you do is this kind of analysis to find some peer agencies that you could be benchmarking against. Great question. Any other questions out there? Again, if you're gonna type something into the group chat, just quickly say that you have a question and then type the full question in there. And that way we can make sure we don't leave on anybody. And again, while everyone's waiting for this, please take the survey. There's a link in the group chat that Undine has provided for everyone to be able to click through and answer. Okay, seeing no more questions, it's a bit early, it's only 12:40, but I think I'm gonna go ahead and end things, and it looks like I'm getting support from Undine for that. Thank you again to everyone and to Stride for funding our research, and I hope everyone has a great day. Thank you. Undine says she's going to send out a copy of the webinar next week if you would like to see versions again. Great. Thank you all.